All right, so in problem 5 we have the age of men and women versus years, the age difference. So basically what's happening is as time goes on, the age difference is getting less and less. Okay, so they gave us the summary statistics here. Okay, the one next to the intercept is the y-intercept, and the year is over here is all this information about the slope. So basically we have to do a hypothesis test. So let's go ahead and do that. Here's what we're going to do. So the parameter here is going to be big B, and that is the linear relationship between age difference of men and women and time in years. Okay. The hypothesis, the null hypothesis, is that big B is 0, or there is no linear relationship. And the alternative hypothesis, I believe big B is less than 0. There's a negative linear relationship. The assumptions, the scatter plot is straight enough. Okay, then we have the residual plot. The residual plot's right here. There's no pattern. The histogram of the residuals is roughly unimodal and symmetric. Okay, so the residual plot shows no pattern. The histogram of the residuals is roughly unimodal and symmetric. And then the last part is obviously independence. So each year's difference is independent. Named test, we're going to do a linear regression t-test. Test statistics. Well, we know that the slope is, all of our information is like right in here, right in this deal here. The top row is the y-intercept, the bottom row is the slope. So b sub 1 is negative 0.023, and actually negative 0.024. The standard error equals 0.00055. b sub 0, or the y-intercept, is 49.9. So n is 24, and degrees of freedom is 22. So how would we write this line? We would write that the predicted age difference and under that I'm just going to put male minus female equals 49.90 minus 0.024 times years since 1975. So that's what our equation looks like. Obtain P. T equals B sub 1, negative 0.024, minus big B over the standard error. And we already know what the T is. It's negative 4.35. given in our table. It's all right here. It's all right here. So there's B sub 1, there's standard error, there's our t-value, and there's our big p-value. So really all we got to do is draw a little sketch. I always like to draw a little sketch. P equals 0.0003. So we're going to reject at the 0.05 level. And then we're going to talk about since big P equals 0.0003, there is strong evidence that the age difference is decreasing as time goes on. And then I always like to refer to R squared. So R squared is right up here. So I'm going to talk about the variation. So 46.3% of the difference, the age difference in age of first marriage is explained. You can either put explained by the least squares regression line or explained by the variation in time. And then I always like to find out what R is, so I'm just going to do the square root of 0.463. And it's 0.68, and obviously R would be negative here, so R is negative 0.68. So there is a moderate negative linear relationship between age difference of first marriage and time. So that's it. Men and women is explained by time in years. And then all I would do is I would then do, to get R, I would just do the square root of 0.463. And R is in this case, R is going to be negative 0.68. So the trend is a negatively moderate trend. Okay.